Hello, how are you? Okay, so today I am going to discuss again regarding geometry. A lot of times I saw that the students are very confused in geometry, especially in the chapters for triangle. Today's class is mainly of about class 9 and class 10. All of you know that in class 9 and 10, either in CBSE or in ICSE, there is a chapter called triangle. So today, I am trying to give you some clues, some help, some hints in triangles. Okay, triangles. All of you please take a pen, a piece of paper or a copy for taking some notes, because there will be something which you will not get in your books. So better you just note it down. Sorry. The thing is, in geometry, it's an application. You know what application means? Like, suppose I list out 5 formulas, like the algebraic identities. A plus b whole square, a minus b whole square, a cube plus b cube, a cube minus b cube. Then I give you a exercise. It will be very easy for you to do the exercise, because you know that okay, this is for a square plus b minus b square formula. So just let me put a square minus b square, I will get the answer. But in geometry, what is the problem? There is the thing, you have to understand the diagram. So the first point I want to tell you, please, again I repeat, please draw the diagram before you approach any sum. Is that clear? Fine. Second thing what I want to share with you, that is, geometry is totally about concept. Okay? You have to put in your brain the concept. Like suppose triangle. Today we are discussing about triangle. So it's not that for the first time when you are in class 9 you are hearing the word triangle. From very beginning, maybe class 5 or 4 I think so, you have heard the name triangle. You know there are 3 lines in a triangle, and this type of figure, that is called a triangle. You know that there are triangles, there are 3 angles. You know that the sum of the angles are 180 degree. So now in class 9, all you have to jot it down and then do the sums. You cannot say, sir, you didn't teach me that the sum of the 3 angles in a triangle is 180 degree in class 9. It's the previous class. So why should I use that one now? Yes, you have to do. Whatever you have learned from the very beginning, all you have to apply. All you have to apply. Clear? So triangle. I believe all of you have seen a triangle. This is a triangle. Good. Now in triangle, what are the things are there? You can see there are 3 points. 1, let me name it A. 2, let me name it B. 3, let me name it C. So in a triangle, first of all, we get 3 points A, B, C. What are the names of these points? These points are called the vertex. Vertex. The students of class 9 and 10 who are watching this video, don't get upset. Don't think that Sir is discussing something which is of class 4, class 5, class 6. Wait, you will get your topics. I am just starting from the very beginning. Clear? Okay. So A, B and C are the vertex. Then what is there? There are 3 sides. The students of higher classes may be thinking that these lines are equal. Yes, you are right. This sign is equal, but for right now, just forget about that. Just I noted to note these lines. Clear? So there are 3 lines. these lines you can see arms or sides. Sorry. What else? We get three angles. Let me name it A, B and C. So in a triangle we got three angles. These are called angles. Is that clear? Okay. Now these three angles you see, they are inside the triangle, interior part of the triangle. This is a figure, it is inside the triangle. And again, if I just extend this line, say name it D, so here also I can get an angle. Can I get it or not? Same thing, if I extend it this side, I will get an angle out here. If I extend it that side, I will get an angle out here. So these angles are called interior angles, and these angles are called exterior angles. The students who are watching this video may be thinking that, sir, why Sarah explaining us these things? This all we know. Yes, you know, I know that. But believe me, still I got some students of class 9, class 10, even in class 12 also they don't know which one are the exterior angles. Clear? Sometimes they have said they have asked to the exterior angle. Which one is the exterior angle? Okay. Okay, so more or less these are the parts of an triangle. A triangle, the side which is downwards, means suppose there is a plane here. Now the triangle is standing here. A triangle is here. So here there is one side or one line or one arm, whatever you can say. We call that one the base. So this is the base. So if anybody asks you, so if anybody asks you which one is the base of the triangle, the down side, the bottom part, the bottom arm is called the base. Now, here is one thing I would like to share with you. A triangle I can rotate. Like this triangle, I can also draw like this. Just I move this one. That means A comes this one, this is A. C comes, when I move this triangle like this, C comes here and B comes here. You got my point or not? Like suppose this is the triangle. This is the line BC. Okay? This is B, this is C. Now I just rotate. So how it becomes? The C comes this side and B here. Got it or not? So C came here, B got here. Now when I turn the triangle like this, or when I rotate the triangle like this, that means which one is the base? At that point of time, this one becomes my base. So what I can conclude? In a triangle, I can take the base according to my convenience. It will come. You have to do that. When you will have to find out the areas of triangle, because what is the formula? Half into base into height. Even these things you have to apply in mensuration also. So is that clear? Have you noted all the things? If not, pause the video, note all the things, and then again continue watching. Okay. Now, again let me draw the triangle first. Let the names be also same, A, B and C. Now I am going to explain and show you some terms, some technical terms due to which you cannot do the sums, like median, orthocenter, in-center, all these things. First of all, as I concluded that part, that base. So in mensuration we get the formula of the triangle. The area of the triangle is half into base into height. Now can anybody tell me what is the height of the triangle? What is the height of the triangle? The height of the triangle is, choose any vertex, A, B, C, whatever you want. Let me choose A. Just draw a perpendicular on the opposite arm. Draw a perpendicular. Perpendicular means 90 degree. Perpendicular means 90 degree. So AD. AD is the height of the triangle ABC. Is that clear? Good. Now in the sum mensuration, if they say that the AC is 5 centimeter and the height of the triangle is 4 centimeter, how will you find out the area? So when this is, you will be considering the base, then this one will be the height. Just rotate it. The previous diagram I showed you, just rotate it. And similarly, this one is also the height. So these are called the heights, or you can say altitude. Altitude. Understood? Now can you see one thing? In a triangle, how many heights can you get? 3 heights. Why? Because there are 3 sides. And what is the height or altitude? Perpendicular drawn from a vertex to the opposite side. So how many vertices are there? 3. So you will be getting 3 heights or 3 altitudes. Now see, not only in this diagram, you can try it out. In any diagram, all the 3 altitudes or all the 3 heights will be passing through a point. Let's name it O. They will all meet at a point. Now there is a special name for this point. This point is named as orthocenter. Sorry. This point is named as orthocenter. Is that clear to all of you? Sure? I'm going to rub it, huh? Okay. Let me just rub this part. The triangle still I need. So I am not rubbing the triangle. Have you ever heard the name median? Yes, you have. What is the median? Well, can anybody tell me what is the meaning of a median? Mid. What is the meaning of mid? Half. So, half or the midpoint of the 3 lines. Suppose BC the midpoint is D, AC the midpoint is E, and AB the midpoint is suppose F. Clear? Now let us draw a line, the vertex and the middle point. No perpendicular. I am just joining the vertex with the middle point of the opposite side. Understood? The diagram is not a straight line, but just assume that it's a straight line. So what is the median? The median is the line joining any vertex with the middle or the midpoint of the opposite side. Mind opposite side. So A is the vertex. Which one is the opposite side? BC. What is the midpoint of BC? D. So AB is the median. So these are called median. Median. Okay. Now here also can you see one thing? All the three medians. Okay. How many medians will the triangle have? 3. Why? How many? Same question. How many vertices the triangle have? 3. So how many medians can you get? 3. So all total there are 3 medians. And here also you see all the medians are meeting at a point. All these medians will be passing through a point. And this point is known as the centroid of a circle. This point is known as the centroid of a circle. Clear? Okay. So we came across orthocenter, we came across median, we came across altitude, we came across centroid, right? Good. Some more is there. Encircle, circumcircle. Encircle, circumcircle. What is that? What do you understand by the word in and what do you understand by the word circum? In. Just try to think. I already told you geometry is all about applications. Just you have to think. So just think. Encircle means, suppose here is a triangle. Clear? Encircle means this one. Means a circle inside a triangle. This is called encircle. And circumcircle, suppose here is a triangle. The triangle is inside the circle. That is called circumcircle. Circumcircle. This is encircle. This is circumcircle. Clear? Okay. Now how will we get? I tell you one thing. These are the angles. These are the angles. Just bisect the angles. Now please don't ask me how to bisect the angles. You know how to bisect the angles? I hope you know. Here also the bisectors of the angles will meet at a point. This point is called incenter. Incenter. Because if you take this as a center and take this a circle, you can draw. Clear? Okay. Next. Circumcenter. Just draw the perpendicular bisectors. Just bisect this line. You know how to bisect right? Bisector. Perpendicular bisector. So these bisectors will meet at a point, and this point is called the circumcenter. Circumcenter. So here are all the main technical parts: median, orthocenter, centroid, altitude, incircle, circumcircle, and all. Hope by now you already remembered what we have read in the lower classes. Am I right? Okay. Next, there are some properties of a triangle. Again, I need to draw a triangle. Suppose A, B, and C. How many angles are there? 3 angles. A, B, and C. My property number 1 states that the sum of the 3 sides of, the sum of the 3 angles of a triangle is equal to, yes, 180 degree. So A plus B plus C is equals to 180 degree. I think better I need to change my pen. Okay. So the sum of the angles is 180 degree. Good. Next, the next property is, that time I already told you that these all are the interior angles. So these are all the interior angles. Now if I extend this angle, this side, then here I will be getting one more angle. Let it be X. What is the name of this angle? Exterior angle. You remember or forgot? My second property states that in a triangle, the exterior angle is equal to the sum of the opposite internal angles. The exterior angle is equal to the sum of the opposite. See, this is the exterior. So this angle, opposite of this angle is this angle and this angle. This a triangle got 3 angles, A, B, C. Now this C is adjacent to X. You know what is adjacent angles? Side by side. So C is the adjacent angle. C is not the opposite angle. But the property states the opposite 2 internal angles. So what are the 2 opposite internal angles? A and B. So the exterior angle is equal to the sum of the opposite 2 internal angles. Clear? Want to note it down? Please note it. Clear? Okay. Slowly we are approaching to class 9, class 10's numerics. Okay, now a very important, very familiar, very famous term I will be using. All of you maybe were just waiting for this one. Yes, that is congruent or congruency. Now can I ask you what is the meaning of congruent or congruency? The meaning of congruent is same or duplicate. The meaning of congruent is same or duplicate. It's not only for triangles, anything. This pen is a duplicate of this pen. This pen is congruent to this pen. No, this is red, this is black. Cannot. congruent to this one, that means each and every part should be same. Each and every part should be similar. Each and every part will be assuming just like it has been duplicated. That's why there is also a word called CPCT, congruent part of, corresponding part of congruent triangles. Don't worry, later I'll come to this part. Now, again let me draw two triangles. Suppose A, B, C. Here also I draw, let me name P, Q and R. Hope you can see this. Okay. What are the angles? Let it be A, let it be B, let it be C. Let it be P, let it be Q, let it be R. Anything else is there? Okay. Now when can I say this triangle is congruent to this triangle? The sign of congruency is first you put 1 equals to, then you put this sign, a wave. Clear? This is the symbol of congruency or congruent. If I draw this sign, I can say triangle ABC is congruent to triangle PQR. Is that clear or not? Okay. Now, first I will discuss why it is called congruent. Then I will discuss when it will be called congruent. So first, what is congruency? And second, how we will find out it's congruent or not. Means the conditions of congruency. See, congruent means what? Congruence means similar, superposed. It's called, another word you can say, superposed. Superposed. Means, like suppose this triangle I take it out and put here, it will be same. Both the triangles will be same. Means, I take it out and put here, that means A will be with P. That means A will be superposed to P. So A will be equals to P. B will be equals to Q. B will be equals to Q. C will be equals to R. C will be equals to R. Similarly, the arms AB. AB will be equals to PQ. Then BC will be equals to QR. Then AC. AC will be equals to PR. Right? So a triangle got three parts. Vertex, I already done, A, B, C. Got arms, A, B, B, C, C, A. What else? Angle. So this angle, I am taking out this triangle, putting it here. So A will be superposed on P. Means A will be on P. That means A will be equals to P. B will be equals to Q. And C will be equals to R. See, did you get me or not? So if I say triangle ABC is congruent to triangle PQR, then A should be equals to P, B will be equals to Q, C will be equals to R. What is finished? Arms. AB will be equals to PQ, BC will be equals to QR, PR. Arms finished. What is left? Angles. A will be equals to P, B will be equals to Q, C will be equals to R. Any other parts left? No. So from here, what can I conclude? That the corresponding part, see, what is the corresponding part of A? P, B, Q, C, R. AB, this is the arm, corresponding part of this arm AB, PQ. So AB is equals to PQ, BC is equals to QR, AC is equals to PR. Similarly, A, P, B, Q, C, R, the angles are also same. Sorry. So now can I say that in a congruent triangle, the corresponding parts are equal or the corresponding parts are same? Yes, we can say. And this, in short, technically, legally, mathematically, we state as C, P, C, T. Small t mind it, not capital T. Full form of CPCT, I can bet a lot of students, even of class 12 also, don't know the full form of CPCT. Very easy, just apply brain. This is the main problem with our teachers. We don't explain, we don't teach. It's not your fault, it's the fault of us. We don't like to teach. We just want to put in your brain the formula, the answers, the methods, that's all. We only tell you, in the bracket write CPCT, in the bracket write CPCT, finished. What is CPCT? You also never ask. And that's why we are taking the advantage. Maybe. Okay, anyway. So CPCT is corresponding parts of a congruent triangle. Corresponding part of a congruent triangle. That is this one. Listen carefully. This one you can only use when you have already proved that these two triangles are congruent. Because this is only for congruent triangles. Corresponding part of a congruent triangle. I found a lot of copies, not even proved congruency, written CPCT. Okay. Even I found triangle ABC congruent to triangle PQR, bracket CPCT. It's not your fault. Again, fault of us. Okay. So now it's clear that if two triangles are congruent, when it will be congruent, why it will be congruent, how it will be congruent, later. Let's assume these two triangles are congruent. So if they are congruent, then corresponding parts of the congruent triangles will be equal. That means A will be P, B will be Q, C will be R, AB will be PQ, BC will be QR, AC will be PR. Angle A will be angle P, angle B will be angle Q, angle C will be angle R. Clear? Understood? Thoroughly? Okay. One thing I would just like to add out here, otherwise maybe my video will be incomplete. Okay. Here, when I am writing ABC equals to PQR, that is A is congruent to P, B is corresponding Q, C is corresponding R. So, for this statement, I cannot write triangle ABC is congruent to triangle RPQ. You got my point or not? See, angle PQR and triangle PQR and triangle RPQ are same. There is no difference, right? But if I change the name of the triangle, I cannot use this sign, because according to this statement, the corresponding part of A is R, but here A is equals to P. A is not equals to R. B is equals to P because B's corresponding part is P. So if they are congruent, corresponding parts should be same. But here B is not equals to P. B is not equals to Q. So I cannot say these two are congruent, or rather I cannot write RPQ. I have to write PQR. Clear or not? Clear? Okay. Now the thing is, when I can say, or when will two triangles be congruent? A lot of times you face this question. Okay, triangle ABC, triangle QR. When I can say these two are congruent, there are some conditions. Number one, SSS. What does this SSS means? Side, side, side. Means how many sides does this triangle have? 3. So if this AB is equals to this PQ, this BC is equals to this QR, this AC is equals to this PR, then I can say triangle ABC is congruent to triangle PQR. Bracket SSS means according to side, side, side axiom. Clear? Next, SAS. What is SAS? Side, angle, side. Now here let me tell you one thing. You see, the A is in between the two S. That means side, side, and in the middle is the angle. Suppose this side is equal to this side is equal to this side, and this angle is equal. I cannot say ABC is congruent to PQR because SAS, the angle should be in between the two sides. So these are the two sides, in between the two sides means this angle. These are the two sides, PQ and QR. The angle between the two sides means this angle. So if B is equals to Q and AB is equals to PQ and BC is equals to QR, then only I can say that triangle, better I write it for you, AB is equals to PQ, BC is equals to QR, and angle ABC is equals to angle PQR, then I can write triangle ABC is congruent to triangle PQR. Why? SAS. Okay. SAS. Okay. Next, SSS you understood, SAS you understood. Now ASA. ASA means two angles and a side in between the two angles. Okay, suppose this angle is equals to this angle. We will write like this: in triangle ABC and triangle PQR, angle BAC is equals to angle QPR. And also this angle is equals to this angle. Angle ABC is equals to angle PQR. And this side AB is equals to PQ. AB is equals to PQ. So angle, side, angle. Then we can write triangle ABC is congruent to triangle PQR. Why? ASA. Angle, side, angle. Clear? So we got SSS, we got SAS, we got ASA. Next, AAS. AAS. Angle, side. Two angles in one side. Two angles in one side. Will become congruent. And the last one is RHS. This RHS, this means right angle hypotenuse side. So for this, you have to take only right angle triangles. You know what are the right angle triangles? I hope you know, huh? Okay. So here in triangle ABC and triangle PQR, right angle, you see these two are right angles. So angle ABC is equals to PQR. PQR. Why 90 degree? Let us assume that BC is equals to RQ. So BC is equals to RQ. And it's given that AC is equals to PR. So AC is equals to PR. That is right angle hypotenuse. What is AC and PR? Hypotenuse. So AC and PR are same. So right angle hypotenuse side. Therefore we can say triangle ABC is congruent to triangle PQR. See, this is all about congruency of a triangle. When a triangle will be congruent. Quickly note it down. Mainly this part. Very, very important. Okay? Shall I wrap it? Okay. The main parts have already finished. Now there are few things which I need to discuss. I believe all of you have familiar with the word isosceles triangle. Right? What is an isosceles triangle? A triangle whose two sides are same. Right? That means AB is equals to AC. So if AB is equals to AC, we call it a isosceles triangle. Always remember, in an isosceles triangle, the angle, listen carefully, the angle opposite to the equal sides. This is the equal sides. So what is the angle opposite to this side? C. That means C. And what is the angle opposite to this side? B will be equals to B. Actually, the angles I should write like this. Yeah, it will be angle ABC will be equals to angle BCA. So in an isosceles triangle, the angle opposite to the equal sides will be equal. Clear? Just the opposite also. If the two opposite sides of an equal triangles are equal, then we can call it a isosceles triangle. Okay. What else is there in your book? Isosceles triangle got. Next. What else? Let me just go through the book. Inequalities. Okay. Let us discuss something about inequalities. Inequalities. What do you understand by the word inequalities? Very simple, unequal. Right? Unequal. So what is there in equals? Suppose in a triangle, these three sides are not same. Okay? These three sides are not same. Now my theorems of inequality states that if say suppose AC is the longer side, suppose this is the longest side. So according to my inequalities theorem, the angle opposite to the longest side will be the greatest angle. Understood? So angle opposite to the longest side is greatest. Note it down. Just opposite also. If suppose this is the shortest side, so the angle opposite to the shortest side will be the smallest angle. Angle opposite to the shortest side is smallest. Okay. Can I repeat? Okay. Number 3. Any two sides sum of any two sides will be greater than the third side. What does that mean? If I add any two sides, AB plus BC or BC plus CA or AC plus BC, it will be greater than the third side. Means AB plus BC, if I add these two, it will be greater than AC. If I add BC plus CA, it will be greater than the AB. Similarly, the difference of any two sides is always less than the third side. So if I add it up, it becomes more, it becomes greater than the third side. If I subtract, if I less, if I minus, that is the difference of any two sides will be always less than the third side. Clear or not? Okay. And just one thing I would like to tell you, that is, sometimes we come across the shortest distance or height. We don't know which one is the height. In the sum also they don't directly tell us. Always remember one thing. Suppose there is a line and you got a point out here. Now if I ask you, what is the height of this point? How will you find out? Yes, always what you should do, always draw perpendicular from this point. Oh, this is a perpendicular. So the perpendicular distance is always the shortest distance. Whatever line you draw on this line, the perpendicular will be the shortest one. This is the height. This is the altitude. This is the perpendicular. And if you go to physics, this is called, yes, normal. So this is not all about, but a lot about triangles. Okay, two more things I would just like to finish it before I end up the class. Because when I started triangle, I just want to complete it. Suppose this is a triangle. There is a thing called midpoint theorem. Okay, Pythagoras theorem, all of you know? Oh, first let me show you the Pythagoras theorem. Pythagoras theorem. Very easy. What it states? Suppose there is a right angle triangle. Always remember, Pythagoras theorem is only for right angle triangles. So this is a right angle. This is called the base. This is called the height. And this is called the hypotenuse. Clear? So Pythagoras theorem states that hypotenuse square is equals to base square plus height square. Clear? So hypotenuse square equals to base square plus height square. This is Pythagoras theorem. There is a lot of applications of this theorem. And the last one is called midpoint theorem. Midpoint theorem. What is midpoint theorem? Suppose there is a triangle A, B, C. Let us assume or let us think that P and Q are the midpoints of AB and AC respectively. Now if I join these two line points, okay, if I join these 2 points, then midpoint theorem states that two things. Number one, PQ will be parallel to BC and PQ is equals to half of BC. So this is midpoint theorem. This is also, there are a lot of applications in geometry of this theorem. So whenever you will get that there are two midpoints, and if I join this PQ will be parallel to BC and PQ will be half of BC. Why? Proof it's there. No need. No need. Okay? Just remember this theorem that PQ will be half of BC and PQ will be half parallel to BC. Similarly, in any sum, if it is stated or if you have proved that PQ is parallel to BC and PQ is half of BC, you can easily conclude that P and Q are the midpoints of AB and AC. So, my dear students, I hope and also I believe that at least I have tried to solve some of your conceptual problems in triangles, right? But it's not the end. A lot is there, because you know that education has no limit. Even I also don't know the full. I am also at a learning stage. Every day, every minute, every time, I am also learning new things. So keep on learning, keep on practicing, keep on watching this channel. It's your channel only, it's not my channel. People say it's my channel, but no, who am I? It's your channel, because you are watching it. It's for you. So keep watching your channel and do please subscribe, like and share to get more and more videos like this which can help you. Okay? Bye.